section 3.2, graphs of functions. Talking about like vertical line tests, which we've already done, plugging stuff in or looking at a graph, stuff we've already done, a lot of stuff that we've already done. We will look at some graphs on Desmos so that you can see those and figure out like maximum and minimum and that type of thing. So some stuff we've already done, some stuff that might be just a little bit new. Example 3.1, we've done these. You're looking at this graph over here. This is a piecewise graph because there's two pieces to it. Notice that it does not go on forever at both ends. So our domain does not go any past like -8 maybe, and it does not go any past like +7 maybe, I think is where the x coordinate maxes out, okay? So just between those two, that is where we can, that answers part C, I guess. Just between those two is where we can plug stuff in, okay? So f of 0 is what they want us to find first. That means the x coordinate. If the x coordinate is 0, what is the y coordinate touching? Is that 6 or 7? I think it's at 7. 7. So f of 0 is 7. It's touching the y coordinate at 7 if the x coordinate is 0. That's it. Easy. F of 3 means go over to 3. 3 is at 0. Okay? Now, what if they would have said f of 2 instead? What's f of 2? I'm going to add that in here. Oh, 0. Sorry. I wrote 3. It should be 0. F of 2. Where does f of 2 live? It looks like -2, but that's an open circle. And then the other spot at 2 is up at like 6. But that's an open circle also. So if I would, okay, here's where we're at. If we say f of 2, that means where is it touching at 2? If the x coordinate is 2, where is it touching? Well, if you look here, this is where 2 is at on the x-axis. I'm just going to draw my up and down dotted line. So it's touching here basically, but that's an open circle, so it's really not touching. Up here is at 6, but that's an open circle also, so it's really not touching, right? So it's undefined at 2 because it's not touching anything. There are open circles at both spots, so it is undefined at a value of 2. That's going to help us to do part C. We said over here that the x's are maxing out here at -8. It doesn't go past anything. Does that look like -8? I think it looks like -8. Or is it -7? -8, I think, okay? And then over here it maxes out at 7 maybe, or 6. No, 7. 7. I would say 7, okay? So it doesn't go any past 7 and it doesn't go any past -8, but the only other point that we can't evaluate between those two is 2. So how do we want to write this domain? X is not equal to 2. We could do that. There's a couple different ways that we could do it. Do you want to write it in interval notation or in like x is something is less than x, which is less than something? The x one? Okay, so -8 is the lowest my x can be. Does it touch 8? Yes, because there's an open circle, okay? And it's going like this, and is it touching 2? No, so we're going to write it like that, okay? And then it starts at 2, and it's not touching 2, but then it's going to 7. These are my two pieces that I have. The interval from -8 to 2, not including 2, and the interval from 2 to 7, not including 2. Does that make sense? That's my domain. Okay? Now, my range. The range is the y coordinates. So basically, we're trying to figure out what y coordinates are being touched by that graph. How low is the y going? -9. -9 is the lowest y right here, right? It touches right here. Now, is it touching every value at some point? Yes. All the way through? Up to the highest point, which is over here at 7 or 8? I think it's at 8. This guy right here is at 8. This guy was at 7. The hump is at 7, but this guy up here is at 8. Does that make sense?
What?
Okay, the highest point that he touches is this guy right here at 8. Does that make sense? Okay, now, even though he has a jump right here, okay, where he's touching somewhere in that jump right here, and he's touching somewhere in that jump over here. So he is touching every place at some point. Some places he's touching twice. Like here he's touching twice, right? But he's touching at least one point between, what do we say, -9 and +8. So the y-coordinates are between -9 and +8. Or is it including -9 and +8? Yes. So that's what my range looks like. -9 to 8, like that. Okay, and you can do that in interval notation if you want to. It would just be brackets, -9, 8 bracket. Okay. Vertical line test. We've done that one before. I think we did. Did we do that in the last lesson? I'm doing this with my algebra kids right now. So and my calc kids actually. So I don't know who I've done this with and who I haven't. We did vertical line test though. So okay. Determine whether the graph defines a function. So over here, vertical line test. This one is a no. This one is a yes. Because it's only touching once, so we're okay. Make sense? All right, now they talk about increasing and decreasing stuff. Okay? So, even though there's bumps and curves and blah, 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 all that stuff here going on in this leftmost graph, even though he's kind of curvy, from left to right, he is going up all the way through. He's not turning around and going back down ever, right? Even though, even like here where he stalls out, he's still going up, okay? So this is an increasing function. He's decreasing over here for this type of function, okay? And then this one is a constant thing. That is where he is constant, okay? So in these next two examples, they're going to have us determine where he's increasing, where he's decreasing, and where he's constant. And this is where Desmos comes in because you have to figure out where these points are where he stops, right? Those 2 points where he stops and starts becoming constant and blah, 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 okay? So on what interval is the function increasing, decreasing, and constant? Okay, so we've got 3 things going on here. Some graphs don't have a decreasing or a constant, like this one was increasing the entire time, right? So he is increasing on all reals. You see that? This guy is decreasing on all reals, and this is constant on all reals, okay? So that's happening, and they say, determine where it's increasing, decreasing, constant. If it's decreasing the whole way, you just put all reals for decreasing, okay? But here we're going to have some intervals because he turns around and goes back up. So I'm going to move this over here and try to get Desmos on board over here. They do give us a function to type in, and that function is like an absolute value. Yeah, we've got 2 absolute values. So we want absolute value of x plus absolute value of x minus 2. This guy right here. I'm going to zoom him in so I can see these points. And those are easy points. Those are really nice points. Okay? So when we're doing increasing, decreasing, constant, we're looking only at the x-coordinates. Only at the x-coordinates, all right? So from over here, when it's on the left side of 0, not 2. Don't look at this 2. This 2 is gone. We don't care what the y-coordinate is. From -infinity to 0, this function is decreasing from left to right. He's going down, right? So decreasing would be from -infinity to 2, or from to 0. God dang it, then I just did it. -infinity to 0. We're looking at the or the x-coordinate, not the y-coordinate. 2 we don't care about, right? Now, do I do brackets or parentheses? I always do brackets around infinities. What about 0? Is the point at 0 decreasing? That's what we have to decide. Is the point at 0 decreasing? No. You always, on these points, wherever it changes directions, you put a parenthesis because at the point where it changes direction, it is neither increasing nor decreasing nor constant. So you always put a parenthesis instead of a bracket. This guy will always be a parenthesis, okay? Then, what does he do between 0 and 2? Like over here, between 0 and 2, he stays constant. So how do we write that? 0, God dang it, I'm doing it again. 0, 2, brackets or parentheses? Always parentheses, because he is neither increasing nor decreasing nor constant at the point 0 and at the point 2. He's constant in between 0 and 2, but at those exact points he is nothing, okay? And then over here to the right side, what is that interval? 2 to infinity, parentheses on both. Good? Happy with that?
Why do you have parentheses?
Infinity always has a parenthesis. Because infinity can never be touched exactly. Bracket means that he's touching it. You can never touch infinity. Yep. Yep. Good question, though. Okay, good? That's that function. Now go to this other one. We're going to graph the second one. X to the third power minus 1.8 x squared plus x plus 1. There he is. There he is. Oh, man. Okay, now, I like Desmos. I like Desmos a lot. A lot, a lot. As soon as I click on this function and I zoom in, he automatically picks points where important things are happening. Do you see those points just like show up there? Important things are occurring at those places. Those are usually maximums and minimums, okay? If you look at this guy and he's like all the way zoomed out, it kind of looks like he's constant right here, right? That he's not moving, he's unchanged. But if we zoom in, what's actually happening between those 2 points? It's going down. So on this side, it's increasing, then it goes down to decreasing, then it's increasing again. Does that make sense? So you really have to zoom in so that you can see this, all right? So we need to make our intervals. Let's go ahead and do increasing, decreasing. They don't ask for it, but we'll do it again just so that we can locate our maximum and minimum, okay? So increasing is from negative infinity to this point, whatever it is. What do we put down for that point? What do we put down for that point? We don't put down the 1.17, right? Just the 0.4367. Parenthesis, parenthesis. That's where he's increasing. Now, he's not constant, so we don't need a constant, okay? And in fact, he's going to be increasing again. Should we do that one next? We'll kind of chop this guy up. He's increasing from here and beyond, from this point and beyond. This point right here is 0.7633 to infinity, like that. And I put this little u in between there. Do you remember what u means? Union, unity, union with. Okay, so those two intervals union together make up my increasing intervals. Okay, and then the decreasing part is just going to be between those two. So from 0.4367 to 0.7633 and parenthesis. Okay, that's where he's decreasing. Okay, now it actually wanted the maximum and minimum, or they call it, yeah, local maxima and minima, which is the plural for maximum and minimum. But we really only have one max, right? And we have one min. And I can't remember if your book wants like the entire point or not. So we'll give it the entire point. What is the point 0.4367, comma 1.17? What is he? Max or min? He's a max. He's going up on one side and then down on the other. So he is the absolute highest point. Oh, I made this too small. 0.4367, comma 1.1767. Okay, that is my maximum point. Then my minimum point is the other one. Desmos is choosing these for me. I really, really like Desmos. 7633, comma 1.1593. Okay, max and min. 1.195, what, 1593? The other one? 1.1767. 1.1767. Okay. Desmos chooses those points for me. Really, really nice. Okay. But zoom in on these functions so that you can see what's actually happened, because it looks like it's a constant if you zoom out. Okay? Good? All right, let's go back to here. I'm going to flip to the back side. Okay. All right, now, this is going to get a little bit confusing. Not for you calc kids back there, because we did concave up, concave down, increasing, decreasing last year. So you should know this. Okay? There is a difference between increasing and concave up. Okay? Concave up means it's like caving upward. All right? I can have an increasing function that's concave down, and it looks like this. This is an increasing function, but it's concave. It's caving downward. Okay? Do you see the difference? Increasing does not necessarily mean that it's going to be caving upward all the way through. This one's caving upward and it's increasing. This one's caving downward and it's increasing. All squares are rectangles, but rectangles are not squares. I don't know why you're asking me that. Okay. All squares are rectangles, but not all rectangles are squares. Okay, so concave down will look like this. Now this function is concave down the entire time, but it's actually increasing from here to here and decreasing from here to here. So just because it changes from increasing to decreasing doesn't mean that the concavity changes. It's concave down the entire time. Does that make sense? And then this one over here has lots of different stuff going on. This point right here is where it changes from concave down to caving upward, and this is called a point of inflection. They call it an inflection point. It's a point of inflection. I call it a POI. Oh, the memories come back, right? POIs?
Point of information.
Point of information, that's right. I remember you called it. Point of interest, that's right. It kind of is a point of interest. Yeah. Do you remember how to find the POIs?
Oh, it was like the derivative.
Second derivative.
Second derivative.
Yeah. Okay, there you go.
Yeah.
All right. So we're going to go through these. Graph the function, blah, blah, blah. Okay, so I need to get back out of here. Graph the function. Nope, that didn't help. What time do we get out of here? 26. We'll do this one and then we'll stop. Okay, so graph that function. Here we go. They're going to ask us increasing, decreasing, and then max and min and blah, blah, blah. So negative 2x to the third power plus 6x to the second power minus x plus 3. There he is, and I don't see him. There he is. There he is. Oh, it kind of looks like the one that we just had up here at the top. Okay, A, they want us to know the max and min. How many maxes and how many mins do we have? How many maxes and how many mins? One max, one min, okay? And we will put them max at, min at, okay? All right, my min is down here, and Desmos does this really nicely for me, okay? Here's my min. If I just click on the function, it will automatically tell me what that point is. There's my min. My min is at 0.0871, comma, 2.9571. That's my min. 0.0871, comma, 2.9571. Okay, max. My max is located all the way up here. There we go. If I just click on the function, it will drop a point there. That max is at 1.9129, comma, 9.043. That's my maximum point. Okay. Part B, intervals where the function is increasing and intervals where the function is decreasing. I'm going to do that down here. B. Increasing, decreasing. Okay. All right. So, the first thing that's happening left to right is what? What's this guy doing? He's decreasing until he gets to this x coordinate, which is also my minimum value, right? My minimum value at 0.08, whatever that was, okay? So he is decreasing from negative infinity to that 0.0871. You see that? That minimum value had a 0.0871. 0.087. Okay? And then what does he do? In this middle part, he is increasing from 0.0871 until we get to the max. Oh boy, I didn't mean to put a parenthesis there. Comma, that's a comma, until we get to the point 1.9129 on the x-coordinate. That's the interval when it's increasing, and then it's going to decrease again from 1.9129 to infinity. So 2 intervals for decreasing, here and here, and then 1 interval in the middle where it's increasing. It's going up, okay? Now, they want us to, on C, they want us to label all inflection points in the function. Oh man, they're not telling me where the inflection points are. Crap. Okay, so in here, I don't know where we're gonna drop him. We're just gonna say about halfway. About halfway at 1. Let's say our inflection point is 1,6. Okay, usually it's about the halfway point. Desmos doesn't go ahead and drop me a point. We're gonna say it's the halfway point, which it usually is. Halfway point, 1,6 is where my inflection point is going to be. That's part C. 1,6 is my inflection point, or the POI. And then the last thing is part D, intervals where the function is concave up and concave down. Okay, so this is my point of inflection right here. On the left side of that point, it is caving up. You see that? It's caving upward here, upward here. So from negative infinity to positive 1, it is concave up. From 1 to then infinity, it is concave down. It's going down. Down and cup. Right. Concave up, concave down. Good? Happy with that? All right.
Come back here. I want to see if I can do this right.